Good day everyone. So for today's pre-lab, we will discuss experiment 5, the uniform accelerated motion. So the objective of this experiment is to study the motion of a body along an inclined plane, to calculate the uniform acceleration of the body from the obtained data, and to determine the acceleration from the slope of the speed-time curve. So our goal is to get the acceleration on an inclined plane. So the idea here, if the ball roll from the top of the inclined plane, the distances of this ball in each second increases. We will use these distances at each time interval to determine the acceleration of the ball on the inclined plane. So in this experiment, we will do that. So in this experiment, we will use an inclined plane, a certain angle, and we will have here the cart, and in the cart we will attach a paper tape, and this sticker timer will produce the dots on that paper tape as we turn this on, and the cart will roll downward blind plane. The paper tape will be just like this. Okay, so this is the point of the start of the cart. Then as the cart moves downward to the inclined plane, as you can see, the dots increases. So for this case, this is 5 degrees, this is 7 degrees, and this is 10 degrees. Our goal is to observe the acceleration of the cart as the angle of the inclined plane increases. So how can we determine the acceleration of the cart using these dots? So first, you have to identify 55 continuous dots from our paper tape. So for example, this is my first dot. If I will count all these dots, this should be 55. The next one is we have to mark this one as our 0 dot, and we will count 55 dots. So we will count, this one is the first 5, 10, 15, 20, 25 until we count 55 dots. And we have to mark that dots. So here, this will be my 0 dot. So that is in 0 cm of my ruler. This is my 5th dot. So that is 1.5 cm. So this is my 10th dot. So that is 3.6 cm from the start. This is my 15th dot, so that is 6.2 cm. 20 dot is 9.5 cm, and you will place that here, so to the total distance. So for my first 5 dots, so that is 1.5 cm. For the first 10 dots, so from 0 to 10 dots, so that is 3.6. From 0 to 15, that is 6.2. From 0 to 20, that is 9.5 cm. So this is how will you determine the total distance until you reach 55 dots. For the second part is we will get the difference between 5 dots. So for example, 1.5 minus 0, that is 1.5 cm. 3.6 minus 1.5, so that is 2.5 cm. 6.2 minus 3.6, that is 2.6 cm. And 9.5 minus 6.2 is equal to 3.3 cm. So we will place that to the distance traveled every 5 dots, which is this. So here the answer is 1.5, 2.1 cm, 2.6, and 3.3 cm until you reach 55 dots. So for the next one is the average speed. So we have to compute this one. So the average speed is distance traveled divided by time, which is 5 dots. So that will be 1.5 divided by 5, that is 0.3 cm per dot. 2.1 divided by 5, that is 0.42 cm per dot. The next one is 0.52, 0.66, 0.76, and so on. So until 55 dots. So once you determine the average speed, we will now go to the acceleration. So for the acceleration, the formula for the acceleration is final velocity minus initial velocity divided by time. Since there are 11 velocities here, so we can compute only 10 accelerations. So this will be, for our A1, we have to identify what is the initial velocity. So this one, the initial velocity, and this is the final velocity. So for A1, we will use the velocity in between of this table. So that will be, so that is 0.42, that is the final velocity, minus 0.3 cm per dot divided by 5 dot. So the answer is 0.24 cm per dot squared. And that is our first acceleration. For A2, so this is the second acceleration, the 0.42 now will be your initial and the 0.52 will be your final velocity for A2. So to solve for A2, we will have final velocity minus initial velocity divided by time, which is always 5 dot. So that is 0.52 minus 0.42 cm per dot divided by 5 dot. So A2 now is 0.020 cm per dot squared. And for A3, it will be just the same. So our initial velocity now will be 0.52. Our final velocity is 0.66. And we will solve for A3. That is 0.66 minus 0.52 divided by 5 dot. And that will be 0.28. So that is now the answer. So our goal here is to determine what is the uniform acceleration for this trial. So if you will compute this, so this will be the acceleration. And as you can observe, most of this acceleration is 0.020 because as the cart moves downward, the acceleration should be constant. So ideally, the acceleration here should be the same. You have to get also the average of this. So that will be, to get the average, so you have to add all this acceleration divided by 10. So you will do this for 2 trials to observe what will happen to the acceleration as you increase the angle of your inclined plane. So this is an example of the complete table for your experiment. So for the next one, graph this value. So the first graph is total distance versus time. The second graph is average speed versus time. And the third graph is the acceleration versus time. Okay, so for doing the graph, so first, this is total distance versus time. So the pattern of graphing is, this is y versus x. So for the y-axis, it's total distance. For our x-axis, it's time. So if you will check table of your data, so total time should be on the x-axis. So that is 0 to 55. And for the total distance, that is for the y-axis, my minimum value for my total distance is 1.5 and my maximum value will be 46.6. So it means that my scale should be higher than this. So my highest scale here is 50 cm. So I use a scale of 5, 10, 15 to 50. So if you will plot the data, so at 5, that is 1.5 cm. So roughly, you will have this one. So at 10, that is 3.6. So you will have this. And at 15, you will have 6.2. When you completed all plotting all your data, you will not literally connect all the dots. You have to find the shape of the graph or what will be the best fit line for your data. So I hope that is clear. For the second graph, that is average speed versus time. So again, for the average speed versus time, that is 5 to 55. So that is for my x-axis. And for my average speed, so that is a small number. So that is 0.3 as my minimum and 1.36 for my maximum. So for my scale here, so I use every 0.2. And my maximum scale here is 1.6. So as you plot again the data, you will again find the best fit line or the shape of the graph, and you will not literally connect dots. And for the last graph, so our goal here, the acceleration should be constant or uniform. So it means the shape of the graph should be flat or horizontally straight. So it means if I will plot this one, so that is 0.24. So at 5, so it will be here. So at 10, so let's say this is 5, 10, 15, you can do that. So this is 5, this is 10, that is 0.2. And mostly of the data is in 0.2. So you will connect the most dominant value of the acceleration. I hope that is clear for graphing. And for this experiment, you will submit the table for your trial 1, trial 2. The same with graph for trial 1 and trial 2. So that is page 24 and 25. And you will also answer the conclusion and the question for this experiment.